Hi guys, it's Mr. again. Today we're going to look at solving absolute value inequalities. Alright, absolute value inequalities are very similar to what we did in the last section when we were solving absolute value equations. So we had something like that, the absolute value of x plus 2 equals 4. We broke it up into two parts. X plus 2 equals 4, or x plus 2 equals, and then we made it negative 4. We solved inverse operations, x equals 2, or, same thing over here, inverse operations, x equals negative 6. And that was our solution. Okay. Same idea, we're going to be solving, we're going to be breaking it up into two parts like that, and then we're going to have two parts to our solution. It is going to look a little different though. So let's take a look at this one. Absolute value of x plus 4 is greater than, let's say, 12. All right. Remember, we were doing problems earlier in this chapter, and we had or and. All right, we had to kind of go back to that idea. This is a greater than problem. Anything that's greater than, or even greater than or equal to, that is going to be an or problem. Okay, so we have to, remember how we're going to have something or something. It's going to be set up like that. The way I remember is I think it as greater than, and then I remember that greater than is or, greater. All right, so I'm going to break this up into two parts. X plus 4 greater than 12. Okay, so just like when we had equations, copy it down the same way, just take away the absolute value symbols. We said this is an or problem, so I'm going to write an or there. X plus 4. All right, and then just like last time, we made that number 12 a negative 12. I'm going to do the same thing, except here, whenever we change that positive to a negative, it's like dividing or multiplying by a negative, so that symbol has to then change. So that greater than symbol becomes a less than symbol. That is important. All right, so now I'm going to solve. I'm going to subtract 4. X is greater than 8, or I'll subtract 4. X is less than negative 16. And if I were graphing that on a number line, just making a real simple number line, there's 0, there's 8, there's negative 16. I should have made that further. Let's try fixing this. There we go. Then I'm going to do x is greater than 8, circle on 8 going to the right, circle on negative 16 going to the left, and the graph is just like it was when we did our OR problems earlier in this chapter. All right, so that is a solving an inequality where you have a greater than symbol. Okay, greater, greater, always going to be an OR problem. All right, now we're going to have problems like this. Absolute value of x plus, let's say, 3. And this time we're going to do less than or equal to 16. All right, now, less than is always going to be an and problem. Okay, and the way I remember that is I say less than. So just like for the or, greater, I know it's silly. Less than, I'm going to think of less than. Helps me remember. Now, we saw and problems where they kind of ended up like this, where we had the variable in the middle, a smaller number to the left, a bigger number to the right, and then less than symbols. Okay, we're going to start off in two parts, and then we'll put it back like that at the end. All right, so I'm going to break this up into two parts again. X plus 3. Less than or equal to 16. It stays the same, just without the absolute value symbols. I'm going to write that word and in there this time. X plus 3. Remember, we make that a negative 16. Just like in the last problem, though, since I had to change 16 to negative 16, it's like multiplying or dividing by negative 1. I change that symbol to greater than or less than, or greater than or equal to, excuse me. All right, now I'm going to solve. Subtract 3 on both sides. x is less than or equal to 13, and subtract 3 on both sides, x is greater than or equal to negative 19. Okay? If I want to take this and make it look more like this one, I'm going to put my negative 19 to the left. I like doing the smaller number to the left. My 13 to the right. I put the variable x in the middle. They're always going to be less than symbols. And then if there were equal to parts, and there were, we add the equal to. So this really is the same as this, because I could read this x is less than or equal to 13, which is what I have right here. And if I read this one from right to left, it says x is greater than or equal to negative 19, which is what I have there. Once again, if I graph this, just like we graphed these kinds of problems before, let's make a real simple number line. 0, there's positive 13, there's negative 19. Since there's an equal to part, I'm going to put a dot on 13, and it's going to be going this way, less than. I'm going to put a dot on negative 19, and it's going to be going this way, so it ends up being a segment connecting them. Alright, that's it, guys. That's solving inequalities with absolute value. Good luck.